All right, so 4.3 properties of logarithms. We have the product rule, in which you can rewrite the log of mn, m times n, as the addition. Where did my pens go? Oh, there we go. The addition of two logs. So that's the product rule. Notice the bases have to be the same. The quotient rule, if it's division, then you can rewrite it as subtraction of two logs. And then your power rule, if you have log base b of m to the r power, you can bring that exponent to the front and rewrite it as r times log base b of m. Scroll up, don't scroll up too quickly. All right, so let me erase some of this so we can. All right, so looking at single log and then trying to break it up into two different logs, that's considered expanding your expression. So we have log base 4 of 35, and we want to know how can we expand it. The direction is to expand. Let me get this out of here. Yep. Direction is to expand. So we can look at that 35 as 7 times 5. And then if we have the multiplication of your two numbers, we can rewrite it as the addition of two logs. All right. Questions on what we did there? All right. Got the next one. So I did the same thing here. We have log of 10x. Don't forget when you don't see anything. Remember, this is what was here. They assume you know that the base is 10. So I broke it up to write it as simple as possible. Log of 10 plus log of x. And the reason being is because of that log base 10. Because log base 10 of 10 will simplify to just 1. So that's the reason why I didn't break it up into log of 2 times 5 like I did up here. So this couldn't be expanded or broken down any further. But because you have that base of 10 right here, that's why I took that to log of 10 and then log of x. So you always want to write your expression simplest way possible. All right. And then the next one, C, log base 7 of 19 over x. Remember I mentioned before, division prompts you to subtract. And so that's what we did here, log base 7 of 19 minus log base 7 of x. And that's all you can do with that one. All right. So D, applying the same principle of the quotient rule, we have the natural log of e to the third power over 7. So we rewrite it as subtraction. Don't forget your base here is e. So that's why natural log of e to the third power, that part cancels and leave you just 3 as your most simplified expression. So that's 3 minus natural log of 7. All right. Any problems before we go to the next one? So the next one, we're using the the power rule, and we have that log base 5 of 7 to the 4th power. And so all we want to do right here is just take the 4 to the front, and that'll be 4 log base 5 of 7. I should get that away. All right, and then the last one like this, we have natural log of the square root of x. So over here, I was just emphasizing, we have the square root of x, that's x to the 1/2 power. Cube root of x is x to the 1/3 power. Fourth root of x is x to the 1/4 power, and so on. Someone had asked about it. So just remind you of that relationship. Oh, didn't do that. Oh, give my numbers back. All right, here we go. All right, so I rewrote it as natural log of x to the 1/2, because the square root, once again, is 1/2 as an exponent. Then you bring it down front, and your most simplified way of expressing it is 1/2 natural log of x. So basically, whether you rewrite it or not, you recognize that this square root is 1/2 as an exponent. Then bring your 1/2 out front, and 1/2 to natural log, 1/2 times the natural log of x would be a more simplest way of expressing uh, this expression. All right, before we add a few more steps to it, any questions on anything that we've done? All right, so in the next one, we want to expand some more. All right, so we're looking at log base a of x squared times the square root of y. So because we're doing multiplication in here, we can rewrite the expression as 2 logs being added together, the sum of 2 logs. And then we take our exponents to the front. And that'll be 2 log base a of x plus 1/2 log base a of y. So once again, the multiplication says for us to rewrite it as 2 logs being added together. And then you can take your exponents to the front of each log. Any problems? All right, so the next one, log base 6 of the cube root of x over 36 y to the fourth. All right. So now we have division here. So we need to be rewriting this as subtraction. Let me erase this. So we have log base 6 cube root of x minus log base 6 36 y to the fourth. Now the 36 y to the fourth can be broken up further, but notice that minus sign. Oh, that minus sign needs to be applied to everything that's in that denominator that came from that denominator, or everything that's behind it. So when we go to break it up, we can look at it like this, having parentheses. And so this is the result. Notice how both the log base 6 of 36 and the log base 6 of y to the fourth are minus signs. So both of those terms came out of your denominator, the 36 and the y to the fourth. So both of them should be negative or have the minus sign in front of them. So make sure we see that relationship before we go any further. Any problem? Okay. So the next thing we notice is that we have log base 6 here. So when I look at that 36, I will rewrite it as 6 to the second power. So that log base 6 of 6 can occur. And when that happens, that means we can cancel out that and just leaves us with the exponent, which is 2. And then we take the exponents of 1/3 and the 4 and take them to the front. Oh no, what happened? All right, there we go. Sorry about that. And I'll take it to the front. So that's 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. Any questions? Any questions? All right, so next thing we want to do is condense it. Basically, we want to go back in the opposite direction, wherein if you look at our first one here, log base 4 of 2 plus log base 4 of 32, we want to bring our logs together. So we'll be using the same relationships, but in reverse. So because I have addition of 2 logs, that means I will be multiplying what logs are applied to. So log base 4 of 2 plus log base 4 of 32 will be log base 4 of 2 times 32. 2 times 32 is 64. Now I have a log base 4. So if I can rewrite 64 as a multiple of 4, then that will help me to simplify further. And 64 is 4 to the third power. So that will reduce down to just 3. All right. Any questions before we go to the next one? All right. So the next one, we have 2 log of 4x minus 3 minus log of x. Now remember, if our bases aren't the same, we can't do this condensing. So notice in that last one, both of the bases were 4. So we were able to do it. Here, both of our bases are 10, so we're able to do it. But I just want to point out that if your bases aren't the same, then you wouldn't be able to condense these expressions. So we have 2 log base, 2 log of 4x minus 3 minus log of x. So first thing I would do is take my 2 back to being an exponent. So that would be log of 4x minus 3 squared minus log of x. And then the subtraction allows me to turn it into division. So we have log of 4x minus 3 squared over x. All right, any questions, any questions? All right, so let's look at C. We have 4 log base A of x minus 2 log base A of 7 minus 1/2 log base A of y. All right, so first thing I would do is take my exponents back to where they belong, and that gives me 4 log base A, well, log base A of x to the 4th, excuse me, minus log base A of 7 squared minus log base A of y to the 1/2 power. All right. Then to bring them together, I recognize that I have my 2 minus signs here. So that means both of those expressions should go into the denominator. So I'll go ahead and bring them together. 7 squared is 49. And then y to the 1/2. So that's what I, oh. All right. So that's what I did right here. 49 y to the 1/2. Brought those two terms together that were subtraction. And then since this is subtraction, I can bring them together as division. So it's log base A of x to the 4th over 49 y to 1/2. Or you can rewrite that 1/2 as square root. All right, any questions? All right, any questions? All right, let's scroll up. Is everybody good with that one? All right, so we have change of base property. I believe it's the last thing out of this section. We have log base B of M. Normally in your calculator, and I mentioned this before, you only have 2 logs. Now some newer calculators have, and I won't even say newer, some calculators have different options that you can use, like this right here. If you have log, you have a box right here and a box right here, that means they give you the option of using a different base other than your common log or your natural log. If you don't have that type of function in your calculator, then the only 2 logs that you have accessible to you would be the common log and then the natural log. So if that is the case, then you need to use the change of base property in order to be able to find the answer to something that has a base other than 10 or e. So notice what we have here. log base b of m, then I can either use common log of m over the common log of b. Notice the b is in the bottom, on the bottom when you think about basement. So whatever your base is goes down here. And or you can use the natural log of m over the natural log of b. Once again, your b goes down into your denominator. And so, and I'll show you in a second, whether you use common log or natural log, it doesn't matter. Either way, you'll get the same answer ultimately. So let's say if we did a log of 5, log base 5 of 140. If I decide to use common log, I would do log of 140 over log of 5. That would give me 2.14613 on top, 0.69897 on bottom, which would simplify to 3.07. Now, if I decided to use the natural log, I would get different numbers in the numerator and denominator, but I still get 3.07 when everything's said and done. So notice the natural log of 140 is 4.94164. Natural log of 5 is 1.60944. And I still get 3.07. All right. So just have to make sure that the 140 is in the numerator, 5 is in your denominator. And whether you use the common log or natural log, it doesn't matter. You'll still get the same answer. And that is the change of base theorem or change of base property. All right, questions. All right, so that is it for 4.3. Any questions on anything I've said up to this point before we go into questions? I know one of your classmates had a question on a problem, so I want to address hers. Everybody good with 4.3? All right. So some questions, as always, may show up after you get in there. All right. So I forgot who it was that had a question, but I'm ready for you.
Oh, it was me.
Okay, good. Yeah.
It was section 4.2 and it was question 13.
Okay. In the world. Oh, did you have the problem, or you want me to look it up?
Oh, I have it. Okay, so
Okay.
log base 3 of square root of 3.
Okay, you just want to know how to simplify it?
Yes, that was it.
Okay, cool. That's not a problem. So we mentioned before, mentioned this class anyway. I don't know if we did it last class, but mentioned this class how the square root is the same thing as the 1/2 power. And then from there, now that we have these same bases right here, that can cancel out, and that will just leave us with 1/2.
Okay, thank you.
Yeah, no problem. Not a problem. Like I said, I don't know if I mentioned that relationship last class or not, so you're good to go. All right, anybody else have anything else? Anybody else? All right, so next class we will knock out 4.4. And if I'm not mistaken, that is it as far as chapter 4 is concerned. Let me get in here and take a look, make sure. And then we'll talk about how we're going to move going forward. Yes, that is the last section for chapter 4. So we'll do 4.4, and then, like I said, we'll talk about how we're going to operate moving forward. And I'll go from there. All right, somebody in the chat. Yep, not a problem. All right, so you guys have a good one. Be safe. And we'll knock out 4.4 next class. Take care.
Bye, have a good day.
You take care. Have a good one as well. Thank you.